Statistics Lesson 6, using a graphing calculator to solve a normal distribution problem. So we're going to learn how to solve the same problems that we did before, but with our graphing calculator. We need to use the Normal CDF button. I'm going to just highlight this. So we're going to find Normal CDF in our calculator, and it's for whenever we use that when we're calculating area between two z-scores. So Normal CDF can be used in a normal distribution to calculate the area between two z-scores, or the area to the left or right of a z-score value. So for example, if the question says the probability to the nearest tenth of a percent that a data value lies between the interval of a mean minus 0.85 standard deviations to the mean plus 2.3 standard deviations is. So really what it's saying is our z-score to the left is negative 0.85, and our z-score on the right is 2.31, just like our graph shows on here. We want to find the area in between. So on your graphing calculator, how we'd go about finding the area is we want to find the Normal CDF button. So where is that? Well, it's actually not in stats. It's in second vars, into distribution, D-I-S-T-R, distribution. So second vars, and we're going to want number 2, Normal CDF. Always Normal CDF, cumulative, because we want the whole area. So Normal CDF, enter. Now, what do we do here? Well, we're going to put left bound and right bound. So left bound is negative 0.85, so I want it between negative 0.85 and comma 2.31. And then we could push enter. Or we could also add in comma our mean, which is 0, and our standard deviation of 1. So when we have z-scores, you don't have to add the other two parts. You could just push enter, or we can go comma our mean, which is 0, comma our standard deviation of 1. And there's my answer. There's my probability. So there, and it's as simple as that. So, for z-scores, here's that formula. Lower bound z-score, comma upper bound z-score. I like to get into the habit of always going comma my mean, comma my standard deviation, because we're going to have to do that in the future if we don't have a z-score. But you don't have to. I'd get the same answer if I go second vars, Normal CDF, between negative 0.85, comma 2.31, enter. And there it is. Now what do we do if it's between all the way to the left or all the way to the right? And then we need to use infinity. So how do we put an infinity in our calculator? Well, pretty easy. 10 to the power of 99 will be the upper bound region. So 10 to the power of 99. If we're going all the way to the right, that's the upper bound. All the way to the left, or our lower bound, we're going to use negative 1099 to represent negative infinity. So let's look at some examples. Where do they go here? So, Normal CDF, calculating area probability between two data values. So what if it's between two data values? Remember our class example with the flu? And we asked, okay, how long will it be, between longer than 17 days? What's the probability of it lasting longer than 17 days? So we set up our chart. Our mean was 12 and our standard deviation was 3. So 15, 18, 21. And so we want it longer than 17 days. So all of this area here. So before we had to convert it to a z-score. With Normal CDF, we don't have to. I'd write Normal CDF. This is how I'd actually show my work. So lower bound. So we want from 17 all the way to a positive infinity. So 10 to the power of 99, comma. Now we have to put our mean and our standard deviation in. So our mean is 12, comma my standard deviation of 3. So when you enter that into your calculator, so again, it's going to be second vars, number 2. So we're going from 17 to infinity, so 10. So E is second, comma, 10E99, or you could do to the power of 99, the power of 99, comma 12, comma 3. And there it is. And it wants us to the nearest hundredth, so 2 decimal places would be 0.05. So in this example, standard deviation was 12. It wants between 13 and 15 days. So instead of having to convert it to a z-score and using our table, I can use normal CDF, bracket, so what between what two values? The lower bound is 13, upper bound is 15, and then comma my mean, comma my standard deviation. So my calculator, second vars, number 2, 13, comma 15, comma my mean, comma my standard deviation. Push enter, and we want to the nearest hundredth is 0.21. Okay, now if I was showing my work on a test, I'd actually have to write out my calculator, what I typed into my calculator. And so it's that easy. So the formula for between two x scores then is normal CDF, lower bound, comma upper bound, comma mean, comma standard deviation. And so here is what they typed in here. Okay, so for lower bound, remember we still use negative 10 to the power of 99. For upper bound, 10 to the power of 99. It's for positive, for extreme values, right, to the infinity. So let's look at an example. Postal outlets have determined that, using standard mail service, it takes 3 weeks on average for a package from China to arrive at an address in Canada. They also determined the standard deviation is to be 5 days. So standard deviation is 5 days, and mean is 3 weeks. What's the problem with this? Our units aren't the same, so we need to turn 3 weeks into days, so that'd be 21 days times by 7. Determine the probability to the nearest hundredth that a package will take less than 15 days. So our mean is 21, standard deviation of 5. So that would leave us 16, 11, and 6. And so we want, what's the probability of taking less than 15 days? All of this area. So 15. So using our calculator, instead of having to convert it to z-score, I could type in normal CDF. So what is it between? It's between negative infinity and 15. So negative 10 to the 99, comma 15, comma, what's my mean? My mean is 21, comma my standard deviation of 5. So typing this in my calculator, I can go second vars, number 2. So we want from negative infinity, negative 10 to the power of 99, comma, all the way to 15, comma, our mean of 21, comma, my standard deviation of 5. Push enter, and it wants it to the nearest hundredth, so 2 decimal places would be 0.12. And that's it. So we didn't have to convert 15 to a z-score and then look it up on our table. You can do that, but this is another option for you. So the next problem says postal outlets guarantee that a package will arrive in less than 35 days. In less than 35 days. Or the delivery is free. Last month, 8,257 packages were sent from China to Canada. How many of these packages would you expect to be delivered free of charge? So remember, our mean is 21, and our standard deviation is 5. So we go 26, then we went, adding 5 is 31, adding 5 is 36. And they're saying that if it's less, that it will arrive 35 days, they guarantee they'll arrive within 35 days. They'll arrive in less than 35 days. Less than 35 days. So if it's on the 35th day, you get your money back. So we want the probability, in order to find out how many, we want the probability that it was more than 35. Okay, so let's find this out. So in our calculators, normal CDF, so left bound is 35. We want all the way till positive infinity. So 10 to the power of 99, comma my mean of 21, comma my standard deviation of 5. So my calculator, second bars, number 2, so from 35 to infinity and beyond, comma 21 for mean, comma 5 for standard deviation, and that gives us 0.0025 See if that rounds to 6. And it says actually to round, how many of these packages would you expect to be delivered free of charge? So we know there's a total of 8,257 packages times the probability that it would actually be late. So our previous answer, I'll use the exact value, times 8257, and what's the nearest, how many of these packages? The nearest package would be 21 packages, so approximately 21, so 21 packages would be free. Let's look at another example. Calculate the percentage of population to the nearest tenth whose height is more than 1 standard deviation above the average height of the population. So let's draw this out. Always draw your graph. So 0, 1, 2, 3, -1, -2, -3. So it says, calculate the percentage of population to the nearest tenth whose height is more than 1 standard deviation above. So that would be a z-score of 1 all the way to infinity. So normal CDF, our lower bound, so what's on the left is 1 all the way to infinity, 10 to the 99. You could put our mean is 0 and our standard deviation of 1, but since we're z-scores, you don't have to type that in. So second bars, number 2, 1, comma, to infinity, 10 to the power of 99, comma 0, comma 1. And 0.1586. So it says calculate the percentage to the nearest tenth. So percentage, we take our number and times it by 100. So 15.9% of the population is always 1 standard deviation above everybody else. So that's the first part of this lesson. Okay, and this lesson will be broken up into 2 parts. So this is the finishing of the first part. The second part, we're going to go backwards. So how do we go backwards? So we can actually use our calculator. If we know our area or our probability, we can find our z-score or our x-score. So that's with using inverse norm. And so the inverse norm is to calculate a data value given the area to the left of the data value. So always we have to know the area to the left. So given the area to the left of the value, inverse norm can be used to calculate the data value. The mean and standard deviation must be given. So in this problem with Toasty the toaster, they told us that the mean was 4.2 years and 0.65 years. And they said that 8%, he doesn't want to replace more than 8% of the toasters. So let's sketch this. So at 0 is 4.2 years. His standard deviation of 0.65. And he doesn't want to replace more than 8%. So 8% or as a decimal, 0.08. So luckily, our area is already to the left. So how does it give us our score? Well, inverse norm, it's very similar in that you need to know your mean and standard deviation. Inverse norm is in the same location, so second bars, except for it's number 3. So with inverse norm, we put in our area. So our area is 0.08, comma, the mean score is 4.2, and standard deviation is 0.65. That means that 3.28 years is that at 8%. If you wanted the z-score, you just would put in inverse norm of your area. So second vars, number 3, 0.08. So the z-score that corresponds to 8% is negative 1.40. But we want the actual score, so we want the 3 years, 3.28 years. So inverse norm, area, comma mean, comma standard deviation will give you your answer. Okay, so for this example, the company would round down because we don't want no more than 8%. Even if the inverse norm calculation was between 3.5 or 3.99, we'd still only warranty for 3 years because we want it under 8%. So just some more stuff to highlight. So inverse norm is calculating a z-score given the left. So we'd use a mean of 0 and a standard deviation of 1. So it says determine the z-score to the nearest hundredth if 1% of the data values lie above the z-score. So here's our z-score, and we know 1% lies above this z-score. So as a decimal, that's 0.01. Now remember, inverse norm, we have to know our area to the left. So we first have to figure out this area here, which is 1 minus 0.01, because our whole area adds to 1, and so 0.99. So I would enter, what's the area? If the area is 0.99, comma, our mean for our z-score is 0, and our standard deviation is 1. So with our graph, second bars, number 3, 0.99 is the area to the left of our z-score. We always need the area to the left, comma 0, comma 1. So it's not going to do all the work for you, just some of the work. The part where you don't have to look up on the table. So 2.326. So z is equal to, we always go to 2 decimal places. There's hundredth. So 2.33. And there you go. And that's the rest of the assignment. And the homework would be 5 to 10.